Alright, let's look at the ODE, Bernoulli equations. Alright, Bernoulli equation is a almost first order linear equation. So maybe I should write that here. This is almost first order linear equations. Alright, so let's look at this. Right, so if it's a first order linear equation, the form is dy over dx plus some function of x, y, is equal to some function of x on the right. Right, then we can use the integrating factor, which is I equals e to the integral of p of x dx, and the solution is 1 over I integral of I times the right hand side with respect to x. Alright, so let's look at this one. Alright, so first I'm going to divide through by x squared. Alright, so you're going to get, I'm going to write it as a dy over dx instead of y prime. Alright, then you have one of the x cancel out, so you're going to have 2 over x, y, right? And the right hand side is going to be 5 over x squared and y cubed. Alright, so the troublemaker is this guy right here. Alright, because of this, this is not a first order linear equation. Alright, but we can actually use substitution to turn it into a first order linear equation. Right? So in this case, n is going to be this number here. So this tells you that n equals 3. Right? So we're going to make this following substitution. Let v is equal to y to the 1 minus n. So in this case, n is 3, so it's going to be y to the negative 2. Right? Right, so let's take the derivative. So I'm going to try to rewrite this differential equation in terms of v. Right? So here, I'm going to take the derivative. So dv over dx is equal to, right? Put negative 2 in front, y, and subtract 1 from the power, so it's negative 3. Then we still have to multiply by dy over dx. This is just a chain rule, right? So we have that, right? So if we have negative 2y to the negative 3 times dy over dx, we can rewrite that into dv over dx, right? So I'm going to take the original differential equation and then I'm going to multiply by this guy, right? So multiply by this guy, right? So that I can create dv over dx. Right? I'm going to multiply by negative 2 y to the negative 3, right? So first terms times that, so you have a negative 2 y to the negative 3 dy over dx. Alright, so you have a negative 2 then positive 2, so it's going to be negative 4 and over x. Right? Then you have x cubed times, x to the negative 3, y to the negative 3 times y is going to give you y to the negative 2. Right? Then this is equal to, right, negative 2 times 5 over x squared would be negative 10 over x squared. Right? Then y to the negative 3 and the y cubed cancel out, so you just get that. Alright, then remember that here, this expression right here is exactly the same thing as dv over dx. Alright, And remember that this is exactly the same thing as v, right? So the new equation is, so this whole thing is dv right here, dv over dx, right? So you have a minus 4 over x v, which is equal to negative 10 over x squared. Right, now this is the linear equation. So first order linear equation. All right, so once you have that, we can just use the integrating factor. Right, so let's compute the integrating factor for this guy. So I is going to be equal to e to the integral of, right, p of x in this case is sitting right here, right? This is our p of x, right? So we can just say, all right, so you have a negative 4 over x with respect to x. So this is going to be e to the, right, negative 4 is just a number. Antiderivative of 1 over x is natural log of x, right? Then we can actually put negative 4 as a power up here using one of the log property. And e to the natural log cancel out. So you end up getting x to the negative 4 power. All right, so that's the integrating factor. All right, so we can find a solution, right? But remember, solution in this case is v. So this will give us v is equal to, all right, 1 over I, so 1 over integrating factor, so x to the negative 4. Then integrating, all right, right hand side is this guy, and times I, so it's going to be negative 10, right? So this is x to the negative 2 power, then you have x to the negative 4, so it's going to be x to the negative 6 power. And with respect to x. All right, so this is going to be equal to, so we're going to just write it here. All right, then we get, let's see, so it's a reciprocal and reciprocal, so this is actually equivalent to x to the 4th power, all right? Then antiderivative of this guy is, so a negative 10 is just a number. Right, add 1 to the power, so it's negative 5, and divide by negative 5, right? Then you would have plus some constant c. All right, so we can cancel, let's see here, negative 5 and negative 10, so there's going to be 2 left over. All right, then we can just distribute this x to the 4th to the first term, and also the second term. Right, so what you get is going to be, so there's a 2 left over. Right, x to the 4th and x to the negative 5th cancel out, so you're going to have 1x left over on the bottom. And then you have a c times x to the 4th power. All right. All right, don't stop here. All right, remember that the v, there's a substitution. It's v is equivalent to y to the negative 2. So we have, so I'm going to go up here. All right, y to the negative 2 is equal to 2 over x plus c times x to the 4th. All right, so I'm going to just simply take the reciprocal of both sides. Then you get just the y squared is equal to, right, reciprocal would be 1 over, right, 2 over x plus c times x to the 4th. Right, one little thing, since I don't like to have a fraction inside a fraction, I'm going to multiply top and bottom by x. All right, so you get 1 times x is x on top, and here x and x cancel out, you have 2. All right, c is just a number, and x to the 4th times x is x to the 5th. All right, So we got the solution. So therefore, the solution, you can take the square root of both sides, then you would have to do a plus or minus. So I'm going to just leave it as y squared is equal to x over 2 plus c x to the 5th power. So I'm going to kind of leave the solution implicit, but I think this looks a little bit better. All right, that's it. I hope that this was clear.